Hi, students. Sorry I couldn't be with you today. Working on more of your stuff with triangles and starting to look at the area of shapes. And every polygon, every kind of shape you're going to encounter is either going to be broken up into triangles or broken up into circles. So once you know how to deal with triangles and circles, you can find the area of just about any shape as long as you can cut it up properly. And so here's the big idea for today's lesson. And then remember, just check the unit planner to know what pages to work on in your textbook, and then ask questions. You can just send me emails, and I can make videos or cover it when I'm back at school. So here's the basic idea. Let's just say we've got a triangle, and all we know are a couple different side lengths, just something like this. And if I wanted to find the area of this triangle, I would have a hard time. The area of a triangle is 1/2 times the base times the height, but I have no idea what the height is when I look at this. So I can set up the law of cosines here to try to find this missing angle. It doesn't matter which angle I choose to focus on, so I'm just going to choose this angle right here. And so then remember that the angle looks across the triangle at its other side. And so I'm going to call this my angle C, and that's my side length C. And remember our law of cosines, a squared plus b squared minus 2ab cosine C equals c squared. So I've got a squared and b squared, 2 times 13 times 15 cosine C equals 12 squared. Okay, let's see. 13 is 169. This is 225. 2 times 15 is 30. 30 times 13 is 390. 12 squared is 144. You can use a calculator for all of this. Then let's see. If we add those, what does that make? 394, I believe. And then if I subtract 394, let's see, what would that be? 245. 245. And then I'm going to divide by negative 390 here. I'm going to pause for a second because I'm going to find the inverse cosine of this number. And you can always just use Google, but I'm going to pause so I can get that number. Okay, so according to when I Googled it, I did the inverse cosine, and I got that C is about 51.08 degrees. That seems pretty reasonable. So now that was just kind of a review of what we did last week with the law of cosines, but now that I'm using that, here's the new piece. I can actually find the area of the triangle. So if this is my angle X right here, I want to find the height. Remember, that was originally the thing I didn't know. I didn't know the H from my area formula. And if I just go drop this down right here, I can find the height using sine. Now, if I look at this triangle on the left here, the angle that I just found is opposite of the height. And I know the hypotenuse of 13. So I can say that the sine of 51.08 equals the opposite side, which I'm calling h because it's the height of the triangle, divided by the hypotenuse of 13. So all I need to do is 13 times the sine of 51.08, and that's the height. So I'm going to use my phone calculator for this one because it has a sine button. So if you turn it sideways, type your angle, 0.08, hit the sine button, multiply by 13, and I get 10.11. That makes sense as the height. So just to finish things up, my area then is 1/2 times the base, which is 15, because that's the side that goes perpendicular, goes at a right angle to the height, times 10.11. And I get 75-ish. 75.86. Okay. So part of the thing that you're doing today is using this idea that once you have your law of sines and your law of cosines, you can figure out any of the missing pieces about a triangle. And I hope you can imagine how no matter what kind of shape you have, you can cut it up into different triangles. And now that you know everything you need to know about triangles, you can find the areas of those triangles and then find the areas of the bigger shapes. This formula that I just did over here, I want you to notice that the letter H actually was just a side length multiplied by sine of an angle. So you'll see in your textbook, and sometimes you'll see in other places, you'll see something like this: 1/2 BA sine of your angle. Sometimes they'll use that squiggly 0 right there. That's the letter theta to stand for the angle. And that's really just going through this process that I did over here on the left side. Okay, so please check your unit planner for what you're supposed to work on today. Also, make sure you're thinking about your project that is on Canvas as well. That project's coming up in a couple weeks. If you get your measurements done outside of class, then you can do all your calculations in class. Okay, reach out with any questions or concerns. Thank you for watching.